What if you had the right kind of material for a job, namely a metal, but the properties of it just didn't meet the exact specifications? What if all it took was some sort of treatment to make it more ductile or tougher? Introducing the concept of heat treatment. Heat treatment is an effective way to change the properties of metal, and many different treatments fall under this definition. Heat treatment plays an important part in the engineering industry as we know it. It has been around since 1000 BC, later being revolutionized in the 1900s. Today, I'm going to teach you all about the basics of heat treatment, as well as cover the intricacies behind annealing, quenching, and tempering. So, what is heat treatment? Heat treatment started with blacksmithing around 800 BC, and became much better understood in the 1940s when the laws of crystal formation, their structures, and their properties were researched and discovered. Heat treatment works by influencing the microstructures of materials through carefully timed heating and cooling. This in turn influences the hardness, toughness, ductility, brittleness, and other properties of materials. The method and rates of cooling and heating are very important in the various processes associated with heat treatment. So, now that you've heard about heat treatment, let's describe some of the methods used in heat treatment. Annealing is accomplished by heating the material to a certain temperature and slowly cooling it, usually by air. In steels, the effect can be used to soften or create pliability within the material by reforming large grain crystals into smaller grain crystals. In other materials, annealing can be used for stress relief or for negating the effects of cold working. Types of annealing include stress relief, process annealing, spheroidizing, full annealing, and normalizing. Annealing is typically used for making metals easier to machine into complex parts, and occasionally for increasing electric conductivity. Quenching is a method used to improve the hardness of a material. It is accomplished by heating a material to a certain temperature, but after it is heated, it is not air-cooled, and instead is rapidly cooled. This can be accomplished with a water or mineral oil bath. The rate of cooling, otherwise known as the severity of the quench, has a positive direct effect on the hardness of the material. The same applies to the surface area to volume ratio, which has a positive effect on the hardness throughout the interior of the material. Tempering is a special process that usually takes place after quenching. By reheating metal to a high point, but below the melting point, and rapidly cooling it, the hardness and elasticity of the material is increased. This process destroys and reforms martensite to create tempered martensite, an extremely hard microstructure. So, after all that, we've learned about heat treatment and its many various techniques. I hope you understand why and how heat treatment is being used today. And now that you'll know all about it, I highly encourage you to get further acquainted with some of the intricacies behind heat treatment. If you're a student here at LA Tech, hopefully you'll be taking a metallurgy-related course soon. Good luck with further understanding the intricacies of heat treatment.